Hi, this is Jeremy Howard from Fast AI, and I'm joined here by Jono. Hey, Jono.
Hey everybody.
Um, we're going to be showing you today how to build an agent from scratch, an AI agent, not a PR agent or a sports agent. Um, we'll be showing exactly what an agent is. We'll be showing where and why they can be useful as opposed to harmful. They can certainly also be harmful. Um, And hopefully that in itself will be very interesting and useful. But also in the process, perhaps more importantly, we're going to be showing you how you can use a particular approach to learning anything. It doesn't have to be how to build an agent or what is an agent, but an approach to tackle any complex topic that you'd like to learn more about. This is lesson 2 of how to solve it with code. This approach we're talking about is called the Solveit approach. You don't need to have watched lesson 1. Some things might have some more useful context, but it's fine to just keep going here. But before I start, I think, John, I'd be interested to hear your thoughts on this, but I think I'd summarize it as saying, we're not going to show you today how to get an AI to do everything for you, because that would not achieve the goal that we've set out, which is teaching you what is an agent, teaching you how to learn things. The whole goal of the Solveit approach is to create a positive feedback loop for you personally, where you become more and more competent over time. You get deeper and deeper understanding of your craft, deeper and deeper understanding of what you're building and how you're building it. We leverage AI to help learn, but and sometimes we get the AI to even build little bits for us, very small bits, but that's less common. Jono, what would be your summary of, what we're trying to show here?
Yeah, I think that's pretty good. That it's not that the thing we're going to build won't be able to do lots of stuff together. We'll show it doing some of the problems that we're also going to do potentially, but we'll have some good discussion as to why you might want to choose one or the other and where the limitations will be. But also, yeah, I think this lesson 2 being on agents isn't because you need to know about agents. Like the main focus is this is a fun thing to like explore how one does something like this in code.
And I think you'll find it's way easier than you expected, and it's going to hopefully totally demystify it. No, I will add in the video resources links to a couple of videos I strongly recommend you read about why you should care a whole lot about your own personal development and building of your craft at this particular point in history, and that if you fail to do so, you may be kind of throwing away your future in some ways. And so hopefully that will convince you that this is worth doing. So let's dive into it. So the stuff we're going to be showing today is in Python, and I'm using our software platform here, which is unsurprisingly called Solveit. The vast majority of the stuff we show today, you can use any other platform to do the same thing. We think Solveit's a more convenient way to make things go well, but yeah, definitely fine if you don't have access to it. It's if you do want access to it, it's at solve.it.com, and you can just sign up. And I want to show, there's a really nice demo that Anthropic created called a customer service agent. We're going to build this. And as you can see, there's a lot of code, and it does look pretty complicated. But actually, you'd be surprised how easy it can be. So I'm going to show you. So basically, what they do with this code is they create a little mini database with a couple of customers in it, and the customers have some orders. We're actually going to use a more sophisticated version, and I've actually, saving myself a bit of time, I've got it here. So here's my list of orders. This is just like a database table. We could do this in SQLite. This is our primary key. Each order has a key, and then it links to a dictionary of things about that order. Then a customer also has a primary key, and then some information, and then they have some orders. So unlike a proper database, we haven't kind of set this up with SQLite or whatever, but the same structure is basically here. And so what they do in the example, the Anthropic example, is they set it up to have an agent that can answer questions and do actions on this customer service database. So you can imagine this being your company's customer service DB. And so here I've just created some functions. I've created a function called get customer info that gets a customer ID. And it returns customers.get customer ID, or it also return customer not found. Same thing for orders, return orders.get, and cancel order. Check that the order is in orders, and if so, set its status to cancelled, and return true to say I did cancel it. Okay, so that's where we're going to start. And we want to be able to answer questions like, can you tell me the email address for customer C1, for instance? Okay, so when you're coding in Solveit, it's a lot like coding in Jupyter or Colab, if you've used a system like that. So these messages, this is a code message, as you can see, and it uses the same kind of Monaco editor that VS Code uses when you go to edit it. And I can hit B to create a new message. Rather than making it code, I could say prompt. And I could say, oh, that's the wrong button. I could do this. And this little button I clicked here, I've turned off include in prompt, so the AI won't be able to see any of this information, and it can't see any of this information.
So it shouldn't be able to answer this, right?
No, it should not be able to answer this. It's poor thing's probably going to be quite confused. So if I hit submit, so it's like, okay, I don't know. So interestingly, though, it knows what I'm doing, and that's because something it does get all the unhidden history. So it got Anthropic's agent demo, and it's got let's replicate, so it's got all that. So it knows I'm trying to do that, but it doesn't know how. So what we can do is if I hit X to cut and V to paste, I can actually tell the AI that it's actually allowed to use my Python functions. And to do that, in a prompt or a note, you just put ampersand backtick, the name of the function that you want to let the AI use, and then another backtick. Or if you want to get fancy, you can actually even put them in a little list, comma-separated list. But I'm not fancy. So you can put this in a prompt. So you can say like use ampersand backtick get faster info to tell me blah, or you can just any note anywhere, mention it once. And you can see why we'd want to do this. Just because you have something called delete database somewhere in your dialog doesn't mean you want the AI to decide it can delete your database. So this is how you opt in to say, I'm going to let the AI know that these functions exist, and I will allow it to call them. And you don't need any MCP servers, anything in this platform, in Solveit. Like just having it as a function is enough. I don't know if there's anything else that makes it this easy, but if you're using something else, maybe you can go and learn about how to set up an MCP server and you could kind of do it that way instead. But here in Solveit, this is it. And so if I now rerun this message, having moved it underneath here, because it only ever sees stuff above it, and I'll run it again, what it's going to do this time is, oh, hang
You
on,
didn't
did
write,
I do something wrong?
You edited the output without changing it.
Run. Thank you. So I hit Shift Enter to rerun it, and this time it says, okay, I'll look up the customer information for C2. It says, it looks like the customer database hasn't been set up yet. That probably means, I didn't. I never ran this message, so we have no orders or customers. So let's see what happened if you look behind the scenes at the details. It called get customer info, and it got, oh, customer's not defined. Okay, no worries. So I'll run that message. So you can see on the date here that it's just been run. And I'll run this again with Shift Enter, and it's going to do exactly the same thing. And we can see that it's answered customer C2 is jane@example.com. C2 jane@example.com. And we can have a look here in the details. You can see it decided to call this function with this customer ID, and it got back this result. So that might look all a bit magic, like how did that happen? But actually there is no magic to it, and we're going to drill all the way down to the bottom.
I saw some discussion in the chat a little earlier, like, oh, is there a definition of an agent? There's many competing versions, but the general idea tends to be some concept of you have a language model that also has some tools and that's able to operate in a loop, deciding which tools to use or which actions to take. And so that's the kind of functionality. The idea here is we'll demonstrate, oh, okay, you've just seen something that is an agent deciding to use one of several tools to answer a question, just right within Solveit, tick some definitions of agent. And then we're now going to start like peeling away the layers of mystery to see like how that works. Yeah, this question, does Solveit replace LangGraph, LangChain? There's lots of different frameworks for orchestrating this kind of thing. And in our opinion, they often tend to overcomplicate the core idea, which is, it can be as simple as just giving an LLM a few tools that it can use, and making it easy to define and use those tools is kind of the way that you make it fun and easy to explore these kinds of workflows.
We don't use those things. So for us, yes, it replaces it, but it depends on your particular needs. So somebody's asking, can you use MCP? And says, absolutely you can, no problem, because you can use anything that you can do in Python. So you can easily have a MCP client here instead. So behind the scenes, Anthropic is trained the model that we're using behind the scenes, and we're passing Anthropic all the information it needs automatically by basically using Python's reflection capabilities to figure out exactly what's available here and the documentation for it and the comments and everything. And we're giving it all that to the AI and saying, figure out what to call. So there's no particular danger here because the only tools it can call are the tools that we've said it can call. It can't call any arbitrary Python. So these are the only tools that it can use currently, because that's all I've said it can use. So we could say, what is the status of order O2? And again, as we discussed in the last lesson, really good idea to have a good speech-to-text setup. Personally, I'm using Mac Whisper here, but there's lots of good options. So if I submit that, same idea. Now, this is all pretty straightforward, right? All it's done in each case is figuring out a function to call, and it's called the function. And we could do the same thing. So we could say get order details, and these are the arguments that are being passed. So in Python, you can pass a dictionary of arguments with this syntax, and you can see it gets back the result. Where things get interesting, and that makes it more than just a tool call, but makes it an agent, is when it can decide to do multiple things based on information. So a really interesting one to do would be to say, please cancel all orders for customer C1. So we haven't gotten information about customer C1 before, right? So it's going to have to first of all find the orders for C1 and then go through each one of them and cancel them. So when we call that, I'll first look up customer C1. This customer has 2 orders. I'll cancel them. It says it's canceled them. And I'll say, great, please double check the status of those orders to confirm the cancellation went through successfully. Okay, so that's an agent. And this might give you a sense of actually why we built Solveit, because we're an R&D lab. And most R&D labs aren't building stuff like this. But our R&D lab is unusual in that the goal of our lab is to figure out what AI is good for, so that we can help improve society by making that available to people. We're a public benefit corporation, and that's our chartered public benefit. So we needed a way for anything we could think of to be like, well, is AI good for that? And if so, how do we make it work really well? And so we built this so that we don't now have to go away and create a customer service agent system. We can just create anything we can envisage straight away. And I'll share this dialogue in the notes when it's done. But we have a lot of interesting stuff at our parent company, Answer AI. For example, we own a law firm called Virgil. And the reason we own a law firm is because we figured out that AI is pretty good for doing law stuff. And so our lawyers live in Solveit. They do their contract drafting, they do all their research and so forth pretty much in Solveit. My co-founder, Eric Rees, the author of The Lean Startup, has a new book coming out, which was written in this environment. He didn't have AI write any of the words for him, but he used it for his fact checking and for checking for any possible issues and, just to provide this kind of canvas. Yeah, so that's what. So this is what an agent is, right? It's something that has is an LLM that has access to some functions. These functions are written in Python. Python is a Turing complete programming language. So now your LLM can do anything on your behalf, including doing things that then lead to it doing other things. How are we going, Jono? Is that a reasonable description?
Yeah, I think that's relatively clear. And so the promise of this lesson is that we'll build something like this for ourselves, yeah?
Yeah, exactly. I mean, we kind of have. This is the highest level of build it yourself. We have now built an agent.
Mm-hmm.
And so most of actually the agents I build nowadays, this is how I build them. But let's go deeper and deeper and create some more interesting agents that are going to be a bit more fun. So one thing that I kind of like to do as I go is to kind of keep my things nicely organized. So you can see I've got a little markdown header here, which is a note. And so if I now go to the next bit, we will create a new section.
There's a question, do we get to see how Solveit implements the agentic features we just saw? Yes, the piece that we'll be building up is very close to what's running behind the scenes. And lots of questions around visibility. Yeah, everything above the message that you're currently, the prompt that you're currently executing, everything above that is visible unless you've clicked the little eye icon to hide it, or you've got so many things above it that they start to go out of context. But for the most part, it's everything above. The AI can see what you can see, all the notes, code, outputs, etc.
So we'll say, okay, creating our own. Actually, before that, we'll do using tools to explore and learn. Okay. One of the things I find agents really good for, and a lot of us at Fast AI find it really good for, is to learn about code and about code bases and kind of to answer questions about how things work so that we can then figure out how to make them better. So we actually have some built-in tools for this, and you can bring them into your environment by typing FC. Actually, let's just make sure I've run the first. Okay, by writing FC tool info. And that actually uses something called dialogue metaprogramming to insert some messages in here, which is nice. And that's going to set up a set of tools for me. And the tools is going to be, if you've used RG before, it's like grep. There's something to run grep to search for things. You can run sed, which lets you modify files. And then it's got various view, create, insert, etc. functions to modify. And so this is basically the set of tools that, for example, Claude Code has access to. So we should be able to do pretty much anything that we do with Claude Code. So today we're going to be learning how to do a tool loop. That example I showed of orders and customers and so forth is actually from also in the documentation of this library we created called Claudette, which actually has something built into it called Toolloop. And that's actually what we use inside Solveit. We're actually using Toolloop. So the best way to kind of dig into how do agents work is let's see how this actual one works. So we could start doing that by bringing that information in. So we can say from Claudette, we'll bring in what it's got. We'll also do from Claudette.toolloop, we'll bring in what that's got. And, in this kind of environment, one of the nicest things I think you can do is to kind of instantly find out about anything you're using by first of all hitting the question mark button to get some quick documentation about something, or double question mark button to get the full source code of something. And one of the things that question mark does is it tells you exactly where that is created. And so what we could do is to help our agent to, it's going to tell us how Toolloop works. How is it built? And then we could use that to dig into it. So to help it, let's cd into the directory where that is. Sorry, %cd. Let's see, we'll say, great. I want to learn how Claudette's Toolloop works. Can you please read the documentation to see how to use it, and then use your tools to investigate the source in the current directory and show me how it's all put together. As you use your tools, detail what you're doing and exactly what you find out along the way. And again, we can just help it out a little bit. So it can search just fine, but we may as well, since it's here, let it know where the information is. So look at that. And as you can imagine, we have a tool to read a URL. For instance, we have a tool to search the internet and so forth. In this case, I wanted to think a bit more carefully about this and take a bit more time. So I'm going to click on the Use Thinking button. This is going to take a few more seconds up front for it to think through the process, kind of reasoning, as it's called. And I'll say Submit. So that's what these little brains are. That's its thinking. So it's going to read the docs.
And so just to step back, what's going on here, we have this library that we've imported, Claudette, and there's a chat thing within this Claudette library that we want to understand, right? So this is like an external library. You could just as easily import plot from matplotlib or some piece of NumPy or some AI library, whatever you were interested in understanding. We've just figured out where that library lives on disk, and then we've told Solveit to say, hey, use your tools for reading files and searching. Go and figure out how this piece of code that we've imported works.
Yeah. And so it's quite fun to see what it did. And so you can actually see what in Solveit, what its tools are that it's using behind the scenes. So in this case, it used a tool that's actually built in called read URL. And by the way, if you're interested in understanding how read URL works, end keys now not working on this keyboard. We could just type in read URL, question mark, and you can see the source code for read URL. So there's nothing so all of our tools are just written as Python functions. We just use these exact approaches internally. So it read that URL and it got back the web page. And then it's like, okay, I see how to use it. Let me read the source code. So first of all, it viewed the directory it's in to find out all the files there. Then it viewed toolloop.py. And then, okay, it discovered that Toolloop's using something called chat. So it needed to know where chat is defined. So it used RG and said up to 5, look for chat in core.py. Got back the result that it's defined here at line 420. It's kind of cool, isn't it? You know, let me view the chat definition. So it looked at core.py line 420 and got back the chat definition. Cool. And then it saw that called call, and then it called toolres, and then it used tools. So at this point, I kind of just wanted to tell me what it's learned, or just to figure out what to do next. So we have a shortcut key, which is just Command-Shift/, which basically means, okay, what did you learn? Where did you get up to?
And this is like continue because there's a limit on how many two calls we do before we stop. Like this, in this case, it's done 9 or 10. We start it.
Yeah, or it could just be that
continuing to
it ran
do
some
it
stuff,
forever.
or I ran some
Yeah.
stuff. You know, it just means, you know, it's just basically saying to the AI, you decide what to do next, and it might just say like, hey, I think we've got all the information we need. So
This is going a lot
probably
deeper
going into
than
more detail than we need. That's okay. Great. So I might just tell it like, that's probably enough detail at this point. Can you give me a detailed explanation of everything you've learnt, please, about how this works, and suggest some approaches I could use to learn more about it? So this is a really good use of agents, in my opinion. We're not using it to outsource our work, but to actually become more competent. So we're learning about something we didn't previously know. And this is saving me quite a bit of time. And it can help me explore this, you know. So like I could either start poking through the source if I wanted to, or I could ask it to show me the bits as it goes on. And so here's some suggestions about things that I could try. So I think this is pretty good. What's still going? Great. I'm going to close these up. So if you hit O, that closes up the output. Just makes it a bit more tidy for me. And let's, what I actually really wanted to show you here is, you know, it's a pretty small set of tools, and it may look kind of magic, but it's not at all. So for example, you saw it ran RG. Well, what is that exactly? So again, we can just type RG and find out. And actually, it's a single line of code. It's like, well, that's cheating. It's calling another thing called run command. So what is that exactly? Run command. Well, it's only running 7 lines of code. And so the key thing it's doing is it's getting a command to run, and it's calling run. That's just Python's built-in, what is it, subprocess.run or something like that. So we could, you know, do, for example, so you can, if you hit W, it takes the code from the output and creates a new message with that code. And you can see here that it's passing, can disallow a particular regular expression, or it can allow a particular regular expression. So if we wanted to make sure that the AI was never doing anything in a parent directory, for instance, you know, we could actually override this and say disallow RE equals anything with 2 full stops in it, for instance. And so that would mean that now anytime the LLM attempted to run RG, if it tried to access a parent directory, it wouldn't work, you know. So yeah, that's all it took. And you know, we can look at a few more. So it also used view, didn't it? And it used view to both to list the directory and to look at a file. So we could do the same thing with view. Okay, still fits on a screen. So it gets passed a path. Remember we saw it try to view a file and like a particular set of lines in order to look at the definition of chat. So it creates the path, makes sure it exists, sees if it's a directory. If it does, it lists it out. Otherwise, if it's a file, it reads the text, grabs the range if you wanted one. That's it, right? So it's not magic at all, right? So these particular functions were predefined in this fastcore.tools. And so this is like the set of functions which, we think are the ones you probably need to explore your file system, to make little edits, to basically kind of be like Claude Code, basically. But you can easily add more. And, this is where you might want to be a bit cautious about, some of these like insert or stir replace can edit files on your file system. And so if, something that can be quite helpful is you can actually create a new instance. So each instance in Solveit is a whole separate Linux virtual machine. And so then you can play there to your heart's content and there's not, you don't have to worry. Or, of course, you could just hit the enable versioning button. And then every time you save, it's going to create something called a git commit. So if you hit S, you'll just automatically get a git commit, so you can always undo. So there's a few kind of ways you can try to avoid getting into a nasty situation there. Once it's in Git, it's pretty hard for any tool to delete that. You don't have to set up GitHub or anything like that. You just click that button, and it's all done.
So Jeremy, I want to ask you, so we've been inspecting the tools themselves and seeing that they're just Python functions. But the title of the section was like using these tools to explore and learn. And we kind of ran the agent, but we didn't actually read any of the results, which I think is how most agents are used. But I just wanted to check what is the sort of outcome that we're going for here, other than seeing that these other tools are useful? Did you want to view its output, or is that still coming next?
So I'm not going to go through this. I'm actually going to go through all this because I already know how it works.
Right.
So
okay.
I'm going to take people through this myself. I mean, this is pretty close to how I would do it, to be honest.
Right.
So it's like, okay, in fact, this is basically what we're going to do next. It said, hey, try creating your own tool and then create a chat class passing it and then call Toolloop. The only problem is the tool they've created is boring. So I'm going to do this with a more interesting tool. But this is remember the kind of the purpose of this was to say, hey, here's how other people can learn
right.
how to learn things. So if you're interested in learning how to create your own agent loop, you can follow the steps in this video, or you can have Solveit or any other AI try to teach you. So let's go ahead and do that. Oh, now my 3 stopped working again. Great. Okay. Creating our own tool. That was meant to be a note, so I'll hit Command-Shift-K. Remember, we've got the keyboard shortcuts on basically everything. C means Command or Control, depending on what you're on. So actually, the tool I want to create is the most dangerous possible, but most crazy fun tool, which is to give it access to all of Python. So what can go wrong? Give AI access to a Turing machine connected to the internet. This is the bit where it turns us all into paperclips. So if that happens, I apologize. So to give it access to Python, there's a number of ways to do it, but I've actually created in the past a little thing called get shell, which is a little Python shell. So we can just import it and we can use it. And maybe we'll have a quick look at some of the documentation for that. Or, maybe actually we could just say hey, I've never used this particular shell implementation before. Could you do a bit of a search and tell me roughly how it works, please? Okay. So, these are the 2 approaches you can use to learning to use some new library or API or whatever. Personally, my approach normally actually though is to go to the documentation for it, because like it's pretty easy to read. Oh, okay, I get it. That's how you do it. It thinks I want to know how how it's implemented, which actually I don't. And that's because previously I was asking how something works. Okay, fair enough. Okay, so while that's happening, so this is interesting, right? It actually wants to find out what's in this, and we didn't give it access to dir as a function, so it wants to do this. So to do this, I'll hit W, and that will pop that out into a message, right? And I'll run it, right? And then I can hit Command-Shift/, and that will allow it to continue with that information. So this is a really nice way, like, is instead of always using tools, is to kind of use this approach where it can decide, what it wants to see as well.
In general, this is like there's a question about, isn't it dangerous letting Solveit go off and do things? For a lot of the work that we do, it's much more like having Solveit suggest some code to run and then running it ourselves and seeing what it is and seeing what the output is. And the tools are much more like, I'd like you to go read a few web pages and come back with an answer from the docs, or I'd like you to go read a few Python files and figure out where some key function is defined.
Anyhow, we're just going to use the docs. And so what I'm going to do is I'm going to, so first of all, basically see, I can say like shell dot, no, I need to be in code, shell dot run cell, say a equals 1, shell dot run cell, just passing it in text that's going to run in Python, right? And it's returning these execution results, and here's my result equals 1. So I want to create a tool that the AI can use to do anything it wants in Python. So I'm going to call it execute, and then you basically have to say, what parameters do you want? And you can see here that I've got some ghost text popping up, so I can just hit right arrow to accept that if I want. By default, you don't get that because by default, you're in learning mode, which is kind of meant to encourage you not to rely on AI too much. And in learning mode, you can ask for a ghost text by hitting option full stop, like so. So we can then give it a doc string. So this is a place where I'm guessing it can probably figure it out for itself. Yep, it did. So I'll just let it write that. So I kind of like to do it just this little bit of completions from time to time. Yeah, so full stop or period. So I'll just say like, okay, get a result by calling shell dot run cell, cool. And then we'll return res dot std out if res dot result is none, else. I better configure this out too. There we go. Okay.
And so for a Python function to be a tool, Jeremy, it needs types so the language model knows what kinds of parameters it can pass in.
Yeah, exactly. So if you didn't have the colon stir, that would not be usable. And it also needs a doc string, so it knows what this is for. And ideally, you should always also put a comment after each parameter so that it knows what each parameter is for. You don't have to. Probably in this case, I could probably get away without it because it's pretty obvious. It's called code. It's in something that says execute code. But I'm in the habit of always adding them because I think it makes it more reliable. So we could hopefully now do this, and it should give me a slightly nicer response. There you go. Okay. So that is now a tool. Now you'll remember we don't let the AI use any function it wants to, because that could be dangerous. So to tell it that I want it to be allowed to use this tool, I can tell it. So I'll say So let's do Advent of Code. So for those of you that haven't done lesson 1, Advent of Code is a fun little programming puzzle thing. And it's got a nice little library that we can use called AOCD, Advent of Code Data. And to use it, you have to make sure that you have an environment variable, or in Solveit, a secret available called AOC session, in your environment.
And if you set that in your secrets, it'll be in your environment as well.
Yeah, exactly. Okay, there you go. So just confirm that it is there. So let me have okay. So to give you a sense of like things not to use agents for, don't have it solve your Advent of Code problems. It would be like using a calculator when you're a kid and you're meant to be solving it, learning your times tables. But just to show we can, let's try this. I want to test the tool that I just created. Please use it to grab the Advent of Code 2024 Puzzle 1 information and example data, and then try to solve the first part of the problem. Tell me your solution when you're done. Have a look at the AOCD docs. The problem is available in the puzzle object. Okay, so remember, anything in a prompt or a note anywhere that has dollar backticks and its name immediately becomes available everywhere from then on in the dialog. Look at the AOCD docs. So again, just give it a little bit of help. Advent of Code data. Let's give it. Thought it'd give me the PyPy. Let's see, homepage. Bit surprised it didn't take me straight there. That's okay. So one little trick, by the way, for pages like this is in GitHub is hit the raw link, and that'll give you the raw, notebook JSON, or in this case, README Markdown. That's kind of what your AI is going to be happiest reading. Great. So I'm going to let it use thinking.
Realized I was confused by a question in the chat about the dollar sign. The dollar sign backtick syntax is to share variables, and so that in the first line of this should probably be an ampersand.
Ampersand, thank you. We haven't done dollar signs yet. That's for a future lesson. Okay, so we've written the most powerful and general possible tool here, which is the run any Python. And it's running it in a persistent shell, so it can import things, because we didn't import AOC D, we didn't do anything much, right? So it's going to have to figure out everything about how to get the data, how to read the puzzle problem, and so there we go. So it tried to do it. Currently the import didn't work. It fixed it. It's finding out how to get the problem. Okay, there we go. It's got 11, which I know in my case, everybody has the, the example data is always the same, but the official data is always different. And I actually remember from last week that is the correct answer. So let's see what happened. It tried to do all this, and it got a trace back. And so then hopefully it actually looked at the documentation. Yeah, it didn't look at the docs at all by the looks of it. That's interesting. I guess it figured it already knew. So it's correct. So it got the puzzle, and there we go, got the problem, and then it wrote some code. So then I'd be like, cool. Great, please write out the source code of your solution and tell me how it works. This is how a lot of people use agents, like they've got an opportunity to learn about something and improve their craft and whatever, and they're like, no, I'll just get the computer to do it for me. And it's actually pretty rare in the world, or at least in my world, where I do a piece of work that I don't want to get better at it, and I don't want to learn anything from it. So like this is not how I would solve an Advent of Code puzzle, but you can. The thing is though, like, and there could be a place for this if you like want to get a proof of concept, have it explore things, explain what it learned, for sure, so it's like, this is, I think we're trying to say there's a nuance here. It's not don't use AI. It's not always use AI. It's definitely not use AI as much as possible. But as you'll see, if you did the last lesson, I kind of showed at the start how I built kind of a series of abstractions to let me use Git in my code better. If you can, develop your craft so you get better at creating richer abstractions, more sophisticated libraries, better understanding of the problems that you're solving, you'll bet in this positive feedback loop where it's out of control. It's amazing. Like, you'll just get better and better. I don't want to brag, but like, people keep asking me, the most common question I get is, Jeremy, how do you get so much done? It's like, well, it's not because I'm getting AI to do it for me, because I'm on this journey of trying to develop my own superpowers. And like, I've seen people ask this about our company as well, which is like, if you look at, we have 9 people total, and the amount of stuff we build and the quality of it, it's out of control. Like, even Solveit, we built it using the framework called FastHTML. We styled it using the styling framework, Monster UI, that we built. We host it on the infrastructure we built. And yeah, it's like, I really think that this approach is a great way to develop, and also just to enjoy your work. I don't know, Jono, do you have any thoughts before we keep moving on with our how to build an agent?
There's a part of it which is that it's extremely hard if you know, like, and just click the button, right, that says solve advent of code day 1. An advent of code's a funny one because you're choosing to do that because it's a puzzle. But I know, even if it's something that I've chosen to do for fun, that when there's that knowledge that just hovering right over there is just the like get an instant answer button, it's very, very hard not to click that. It's very rewarding to feel like, oh, I built this thing. And then you go like, well, did I build this thing? Not really, right? But yeah, it's extremely tricky to like, I don't want to be judgmental of people who, look, your employer is asking you to do this thing and then you have the button that says do the thing. Like, it is very like the obvious answer is to click the button that does the thing. And it's very hard, and requires a lot more like willpower and intention to not click that button. And so we've just shown you, like, even in Solveit, you can have the equivalent to that button, right? You can give it some tools and say, go to town, solve my problem. And it will. You can put it in standard mode and just ask it for all the code and it'll write you 2 pages of code. And so, yeah, a lot of it comes down to that discipline of deciding, okay, this is a case where I'm doing advent of code because I want to get better at programming. I'm going to very intentionally choose to not take the easy route.
It's like a drug with a bad delayed hangover. Yeah, the hangover is like, some people I've heard say, like, a year later after leading into more agentic coding, is like, oh my God, I've not only forgotten how to code well, but I've forgotten that I can. I've lost my confidence. Yeah, I think this is a path to feeling like you're on a happy journey. You're having fun, you're learning, but it probably requires either doing it as a hobby or being in the kind of workplace that actually appreciates human development, rather than maximizing the number of lines of code you show each day. We often write only a handful of lines of code, but our handfuls of lines of code tend to do an extraordinary amount of work. Okay, so let's see how to keep drilling down. So how do we build this from lower level pieces? So how does Solveit translate into production apps? I mean, we're going to show you, right? But it kind of, at the same time, it doesn't. Like, I'm trying to show you how to create a positive feedback loop for you to get better at your craft. So how does that translate into production apps? Well, when you're better at your craft, you write better production apps. You can directly use it to build production apps, and indeed Solveit and our Plash deployment system, and everything we build is built in these tools, but it's not really what this is about. So I just wanted to be really clear here to say is like, the purpose of this is to get better at your craft. This how to become a software engineer in 10,000 hours from Peter Norvig thing. It's like you work at it over a period of years and get better. But I think you can get better faster now. AI can help you, as we're seeing. Okay. And, yeah, maybe that's not for everybody, which is fine. This is for those people who want to do that. But I think, I know a lot of the world's best computer scientists and software engineers, and they basically all work this way. They don't try to get as many lines of code out each day. Okay, so using Claudette's Toolloop. So again, I'm not going to go through all the details of getting the AI or the docs, because I wrote Claudette, so I know how it works. And so the focus here is I want to try and show you, how the Toolloop works, and then we'll keep going deeper and deeper. So Claudette is a pretty thin wrapper on top of the Anthropic API. So if you can use Claudette, you can use the entire Anthropic API and all the models they have. And basically every API looks pretty similar. We actually also have a library called Lisette, which you could check out if you like, which is actually lets you use any model from any provider. I'm using this one because there's less layers of abstraction to understand. I'm trying to get closer to the metal here. So let's grab IQ 4.5. That's a pretty good model, but it's also pretty fast. And so if you looked at lesson 1, you'll notice, again, I'm doing this usual thing of like printing everything I'm going and going in very small steps. It's funny, like a lot of people say like, well, that seems obvious, but I don't know anybody almost outside of Answer AI that actually codes like this. So yeah, it's easy to see what to do, but like you actually have to practice it. You'll never have a bug, or at least a bug that's more than 2 lines of code long. So I want to let's create something super simple, right? So we'll create an adder function. And I'm not going to bother adding comments to these parameters because I think it's so obvious what they are. I'm pretty sure that the AI will figure it out. Okay, so we'll create an adder and we'll create a multiplier. But this is actually going to let us, practice with some agentic stuff, because we can create things that are going to require multiple steps to solve. And again, I can probably let it finish this off for me. Do this one as well. Full stop. Okay. So we could try that. Hardly seems worth it. +2 adder.
Those are separate arguments, right?
Yeah. That's the whole point of it, right? Okay, and I guessed what I wanted there, so that's nice. Great. So I want to test my tools. Can you use adder and multer to solve? I'm just going to type that myself. So it's going to be ampersand, backtick. Well, since I said we can use the fancy approach, we may as well go ahead and use the fancy approach. No, not multer, comma, multer. Solve times plus. All right. So you can see here I've created 2 tools. I've made them available. And so the prompt should work. And so now we're going to, we'll try and do the same thing from scratch ourselves. And check. Or we could also just check that it ran the right tools. Okay. So to do it ourselves, we have to create a chat object. So most APIs are going to have something like a chat object, and we've got to dive deep into it to see exactly how this works as well. Don't worry. We're just going to go through one step at a time. So if you hit Shift Enter, you can find out the documentation for that. So it needs a model, and you can also pass in some tools. So I'm going to pass in my model. Just say tools equals adder, comma, Malter. There's my chat. And so for this to work, you'll need an Anthropic API key secret set. So if you go to Anthropic's website, to their API, not to their Claude.ai, you can sign up for their API, and you can get a Anthropic API key, pop it in your secrets, and then you should be able to use this. So if I go see, hi, I am Jeremy.
So this is no longer using Solveit's built-in AI. This is us somewhat manually using a library to query Anthropic's API directly.
In fact, in order to ensure we don't get confused, you know what I'm going to do? I'm going to hit D. Am I? No, it's fine. We won't get confused. So just nothing above this. In fact, I've got to hit left arrow to fold it all up, right? So, and then, yeah, let's create a new section for this, and then we won't get confused. So this section is already. Oh, I do have a section for it. Never mind. Confused somewhere. Okay. And so when I said, hi, I'm Jeremy, it said, hi, nice to meet you. And because I told it here what its tools were, it also tells me it has some tools available. So that's kind of nice. So then I could say, do you remember my name? I sure hope it does. So these are code cells, right? This is not prompts. So this is stuff you can run in any environment at all. So this is actually how easy this is. I'll hit comma to copy my prompt there, and then I'll hit V, but this time I'm going to say PR equals, this is in a code cell, and we should be able to simply say at this point, result equals c.toolloop, and as you can see that what we're going to expect to pass in here is a prompt. And then immediately we'll see what that looks like. Okay, so it's created something that's not directly viewable. And the reason for that is that a tool loop is something that kind of has to happen step by step. And so Python has a really nice system for this called iterators. And so we can loop through it, and we could print it, we could display it. Maybe we'll start by printing it. Print.
Probably C, right?
No. Yes, probably O. Okay, let's try that again. Print O. Okay. So away it's going and it's doing stuff. It's a little bit hard to read that, but we can say from ipython.display, import display, and this will give us a nicer, richer version of it. So let's do that again. Display. Here it goes. So you can see the similar kind of thing, right? It's doing some text, and then it's, if we look in here, you can see that it's got this tool call block with this input, the name. So you can probably imagine what Solveit's doing under the hood. It is actually using this exact function. And then we called that tool to get the result. And it's gone ahead and done it all for us. So that's what it looks like. It does look a lot simpler still than all this stuff that the Anthropic docs say. And the reason for that is that, we try to make everything very ergonomic. We can do that as well, but behind the scenes, what that's actually doing is using something called JSON schema. And so we can import something to see a JSON schema. And basically, we're automatically generating this. So if we call get schema, most interesting one might be let's look at our EX one from earlier on, the one that it executes. So you can see it's got the description, it's got the name, it's got the parameter, got the type, the description of the parameter. So these are the things behind the scenes that we're generating in order to try to just make this a bit more ergonomic.
So for Jeremy, for someone who's maybe less familiar with how LLMs work, what's happening right at the bottom of our code is we're sending off a piece of text to a model that's used to seeing long pieces of text, right? And it's going to be in a very particular format that Anthropic have defined, where you have a whole history of messages. And some of those messages are user messages, like Jeremy saying, "Hey, I'm Jeremy, hello," and the assistant messages saying, "Hey, I'm here to help." And then some of those messages are us asking it to do something, and it replying back with a request to use a particular tool. And then some of those messages are us sending back the tool results or the tool definition or whatever. So it's this kind of back and forth exchange that ultimately turns out as a big, serialized piece of text that gets fed to the model, and then it generates some new text at the end of that that gets sent back to us. But in between, we're just formatting it in this very particular format of basically a dialogue history, like a chat history between us and the model. And so all of this functionality here, like this get schema, is a way to say, like, how do I take my Python function, turn that into an appropriately, described piece of text. And then all of the chat calls and tool loops, these are just ways of saying, okay, now I'll put a message from me and then see what the LLM says back. And if it's a tool, and so, yeah, it's like just building up this conversation. Is that a fair summary of like the core that's
Definitely.
going
We'll
on?
dig into that. Yeah, we'll dig into that right now, actually. Let's have a look. But before I do, I just wanted to answer this question about we have an app that throws up the hotkeys being pressed. Yeah, we're going to do that from the next lesson. I didn't want to distract from the key ideas here. I didn't want this to become like how to use the Solveit platform, because that's not really the important piece of this. We're trying to teach what's an agent, how are they made, and how do you work step by step. See how we're going like top down, gradually going lower and lower, to kind of understand things fully. And so we'll drop in the notes our link also to the 1.25 hour how to use Solveit video that Jono and I did, and to a full text article version of that, written with the help of Solveit. And and then from the next lesson, we will get much more into the detail of the platform on the basis that anybody who's got as far as lesson 3 must care enough that they want to know more of these details. So thanks for bearing with us. So actually, let me just add with chat. Yeah, so let's look at that, right? To go to the next level, and this is a nice thing about this top-down, go deeper and deeper and deeper approach, which is a kind of a very Solveit way of thinking about things, small steps, printing everything as you go. So in a learning environment here where we're trying to understand this, every time we get to another layer, which is like, okay, we've got chat.toolloop, how does that work? And then we'll see that. And then we'll be like, well, how did that work? History. Okay, and how did that work? So, and actually, I will say the approach I used earlier, which Jono was like asking about what do you do with this, right? Is even if I didn't know how the tool loop worked, I would still actually close this up. I wouldn't read it. And I'd instead say to Solveit, okay, please take me through that, because there's too much, right? And in particular, I'd make sure I'm in learning mode, which is the default. And in that mode, the prompt is going to encourage you to do really small steps. I turned off learning mode for this step because I wanted to show you, what it looks like doing it all at once. Let's have a quick look. So if I hit B, right, you can't see anything underneath. Okay, I could say like, wow, that looks amazing, but it's also kind of intimidating, to be honest. Can you help me take me through this step by step, really slowly? What's the first simplest thing I could do here? Because now it's got all that information, and the information is really for it rather than for me, right? So if I let it answer this question, we can start. Okay, so hit W, right? Here it is. And no, this one looks simple enough. Thank you. Can you show me what the next step is now? So that's what I would do, actually. I otherwise you'd like have to print it out and keep looking back at it. And then as you start exploring, you realize you want to go in a different direction to what it thought, you know. And so here I could, oh, we've got one called M actually. We could show the chat afterwards. We could then hit Command-Shift/ just to let it know that we've run that. We can keep going. And I can hit W. So yeah, I probably should have answered it that way earlier, Jono. Anyway, so we're kind of going through this. And so, yeah, you would do this for loop, blah, blah, blah. Okay, so we're not going to use Toolloop though, right? So let's rerun. Let's rerun this. I'll just pop it down here again. So we've got a nice fresh one to start with. And yeah, I'm not going to use the tool loop. So instead, I'm just going to call the chat directly, just like earlier when I did that "Hi, I'm Jeremy" thing, right? So I'm just going to pass in my prompt, right? And just remind you what that prompt was. It's this, okay? So I'm just going to call that. And it's just said, okay, I'm gonna try to do this now. And it's got this request to do a tool call here. See, type equals tool use. This is a tool use message. It's saying, please use this tool, give it these parameters, run it for me, and then tell me what happens. That's how an agent works, right? That's basically it. Like Jono was saying, it's been trained with machine learning, stochastic gradient descent. Check out the Fast AI course if you want to understand how that works. And it's been basically trained to spit out this particular set of text. Great. And so one of the things that you'll see in the big list of things that came out here is r dot stop reason. Now, it might be kind of surprising if you're used to using kind of VS Code and stuff like that it always seems to know exactly what to show in these lists. And the reason for that is that Solveit and other kind of advanced REPLs like Jupyter and IPython, they do use a very different approach to VS Code. They don't guess what type R is, and then they don't use type hints to find out what it supports. It actually looks inside the Python interpreter and finds out exactly what it is and finds out exactly what it supports. So you don't need any special typing at all to get this kind of really nice, exact information. So here's my stop reason. And so stop reason says tool use. So it said, okay, I tried to answer the question, and I didn't stop because I was finished. I stopped because I needed to use a tool. So the way that Claudette is designed is if you now just pass it nothing at all, it uses the tool, gets the answer, and sends it back. And so we can just keep doing, right? And actually, I should have put that in R. So let me so I'm going to hit merge here. I'm going to start again. Go to new chat, run that, and that. I'm going to put this in R, print that. And the reason for that is I wanted to show you now if I say R dot stop reason, the turn's ended. So at this point, as we've got the answer and it's finished. And if you look inside the chat object, there's an H for history attribute that has everything that's happened. So the user said, I want to test my tools. The assistant said, I'll solve this step by step. And the assistant said, please use this tool with these parameters. And then the user said, here's the tool result. Now, we didn't do that, right? And that's because the chat object, which we're about to replicate from scratch, just called the tool and did it for us, right? And then the assistant said, cool, now I'll do this. And then it told us to use this, and it told us to put in these parameters. And then we, behind the scenes, ran that and told it that this was the answer. And then the assistant said, great, there's my result. And I'll hit Shift-O to turn this into a little collapsed block so that we can see there's the result. All right. But, we're doing this one step at a time. So let's now, automate that. So it should be easy enough. Let's create a new chat. And again, let's call our function.
So every time you make a new chat, you're cleaning the slate in
exactly.
terms of history, right?
Exactly.
That's the reason we're rerunning that piece of code.
Show c.h gives me the history. So there's no history now. Yeah. Yeah. So what Jono was saying, the key idea here is on the anthropic side, the model we're using Haiku. Haiku has no idea what's happened in the past, which you'll see in a moment. It only knows it if we tell it. So we store the history of everything that's happened. And actually, as you'll see in a moment, all of that's being passed back each time. So now it's a fresh one. There's no history. So we're starting again. As far as it's concerned, it's never done this before. So what we can do now is loop it. So we can say, while dot stop reason is not equal to, and my one key is not working. This is where I wonder if it's going to guess what I want. I think it should. Yep, not equal to end turn. So this is kind of nice again with AI. If you forget exactly how to spell it, it's safer just to have it do it for you. Then we'll say, okay, R now equals, just call the next line of the chat, and maybe we'll take a look at it. And that should be our agent. Whoa, there it is. So I think, and each layer we go deeper, hopefully more of the mystery of agents is being unveiled, right? So let's now say doing it manually with no chat. Capital C. Okay. So chat did a lot of work for us, right? Called the function, kept track of the history, all that kind of thing. So before we do that, I'm just going to show you a bit more of like what Jono was saying earlier, which is we'll actually create a chat, right? Never mind about tools for this one. And Jono will have a real evil laugh here. He loves messing with LLMs. So I'm going to say...
for the record, I dislike this.
You dislike this? Well, you always have an evil laugh when we do it.
I have an evil laugh, but it feels extremely wrong to
okay.
do what Jeremy is about to demonstrate.
I take it back. Jono knows exactly what I'm going to do here. Hi, I am Jeremy. Jeremy? Oh dear. Jeremy. There's no Jeremies, are there? Hi, I am Jeremy. Do you know what my name is? Okay, so there's C.H. Remember, I'm telling you, it's passing the whole history each time, right? So C.H0 is role user content Jeremy. Content equals Jono. Anyway, either way, Jono's going to get blamed for this.
You might want to, it's the whole thing, right? Hi, I'm Jono.
Oh, yes. Thank you. Hi, I am Jono. Full stop. C.H. So now if we pass this back this is the history. This is what happened. Jono said, "Hi, I'm Jono." And then he said, "Do you know what my name is?" And it said, "Yep, your name's Jeremy." So we'll say, "Wait, what? Are you sure? That doesn't sound like my name if I remember correctly." So we now have a very apologetic. "Oh, you're absolutely right. I apologize for the error. You're Jono, not Jeremy. I made a mistake." Okay, so you can see here that LLMs don't actually have a memory. They only have the memory that you tell them they have. Okay, so given that, we're going to need to do this without chat. We're going to need to kind of handle our own history. So the thing in Claudette that's the lowest level, that's basically a very direct mapping to the underlying API, which is a pure send text here and there thing, is called the client. So we can create a client. And so, oops, that's a note. That'd be code. And if I hit Shift Tab, I can see, okay, it just needs a model. So we're not passing in tools this time. That's way too fancy, just a model. That's great. So now if I say, "Hi there, I am Jeremy." And now if I say, "Do you know what my name is?" It won't, because I'm not using a chat. There is no history. It's never seen me before. We haven't met. Don't ask me. So that's how the client works. It's just sending behind the scenes. It's just sending network requests with this text, and it's just getting text back. And the text back actually has all this other stuff in as well. And here's the stop, reason, end, turn. So it's all done. No tool calls. It's finished. So let's create a list with our tools. See if it can figure out which ones they are. Yeah, it doesn't know what tools are meant to look like. So if I say adder, comma, alt full stop, Malta, it guessed now. Great. So same basic idea, right? So there's no history here. So if we say C PR, so remember that's our math problem. And now we're going to have to pass in our tools every time. Okay, so let's put that in a response. Okay, so it again, same thing. It knows what it wants to do. So, what might be helpful here, I think, is to just, this is how I actually wrote a lot of stuff in Claudette, is I kind of did stuff, and to kind of figure out what everything should look like. And then I put it together. So we've already got this assistant response. We've got that tool use, but basically we're going to need something like this, right? That's what the history was before the assistant then came back. So I'm going to copy that, and we'll create a note here. Sample history.
So if you're just starting out earlier in your coding and you're wondering how advent of code applies to real life, it's often the case that you end up in something that suddenly feels just like the advent of code you've just been practicing, right? We have some data that we're working with and we'd like it to match some other format, and usually there's an example of what that should look like, right? The Anthropic API might have a demo on their website showing the full JSON blob you should send. And so then the whole problem of how do I create a chatbot becomes the immediate problem of how do I turn my list of texts into something that looks exactly like this history that we need to recreate.
I like this comment. execNB plus tools LM plus fast HTML plus fast core equals solver. That's not at all far from the truth. That's a nice thing about creating nice little abstractions, is we do tend to find we can go really fast now because we just plug together stuff we've made. And when we find something that doesn't exist, we kind of make that little piece. So we've got a few hundred repos. They're all things we've all built them in the same way, which is using what kind of my co-founder Eric Ries would call this kind of lean startup approach. It's like you build something that needs the thing, and then we extract the thing out of it. So we don't start by writing a library. We start by writing a thing that we want to use, and we just kind of do everything manually, lots of repetition. And then we want to do it the second time somewhere else. We kind of pull out the repetitive bits and turn that into a library, refactor the original thing, because now we've got a library that only does exactly what we need. So you never end up with the Yagni, you ain't going to need it thing. You only end up building the stuff that you actually need. And so this question here is, I think, trying to say like, hey, anything you automate, you're going to lose your skill at the thing that like, where does it start? Where does it stop? But like, it's an actually very interesting question that people have studied for decades when they look at things like autopilot in airplanes, and anti-lock brakes in cars. And the question of what's the impact of using more automated things on your ability to do work is complex and nuanced. I used to run a company called Analytic, which was providing AI tools to doctors and particularly to radiologists. It's a huge question. It was like, okay, how do we build tools that allow radiologists to continue to become better at radiology, whilst also taking advantage of artificial intelligence? And I think in the end, you kind of have to study yourself a bit, like I type a lot still. If I only ever used voice, I probably would get a lot less good at typing. But if in the process I found using voice was just as good as typing, I wouldn't care. And this did happen to me some years ago when I got really bad RSI and I couldn't type for 6 months. And only using voice was horrible because a lot of things just are much better done with typing than voice, particularly with code. And it's going to keep changing, so like where's the point where automating something is just as good so much that you never need to do it yourself? It's the point definitely at which, well, there's no point being better at doing it yourself unless you enjoy it. So like I spent a lot of time learning to get better at chess, which is like kind of pointless because computer's better at me chess, and I just did that because I wanted to. At the moment, I find AI coders are really bad at software engineering in particular. They're not bad at some kinds of coding, but they're really bad at software engineering. It's very hard for them to learn software engineering because it's not in the training data. The training data doesn't have many examples at all showing the process of building something or the process of debugging. So it could be that given the lack of training data, maybe AI is never going to get particularly good at software engineering, or maybe it'll get good to a certain point. But I'm always thinking like, okay, well, what's the part of my craft that's valuable to get good at? And so at the moment, I find, being good at software engineering has a really high amount of value. And so I study it and I practice it. But things keep changing. All right, so I think we're getting close to done. We've nearly got to the bottom, which may sound surprising because we haven't actually done much. But there's actually not much to agents, hopefully, as you're kind of seeing here. So we basically need to kind of try to reconstruct this history. And so we've got in this response that we got back, this R. Again, I'm in a note code. Its content is a list, and the second thing in the list is a tool use block. And so I very often, like I'm just often going back and, editing slowly my previous pieces to kind of build up what I need. So you can see in my tool use block, okay, I've got the import. Okay, this is all useful stuff. So I'll call this my tool use block. Look, I'm not enterprise coding here. It's fine. I'm only going to be using this for the next 5 minutes. So TUB, I am not going to forget that TUB means tool use block. So it's fine to use small things for short amounts of time. So in terms of what I need from that, basically what I need to do is to construct this response. So I'm going to need the result. So that means I'm going to need to call this thing. So I need the function. And so I only have the string. And this is where, again, if you can learn a lot about Python by going deep like this. And so I've done this for quite a few years now. So I know that actually in Python, if you type Malta, it's actually just syntax sugar for typing globals, square bracket, string, Malta. There's very, very little to Python in its heart. It's kind of like a bit of a Lisp, really. So this is how I can and I shouldn't write Malta by hand, obviously. I should write tool use block dot name. There's my function, right? And so then I need to call that with my arguments. So as we briefly mentioned earlier, we learned that you can do that by using ***, given a dictionary. And we have a dictionary. It's called input. So it's going to be tool use block dot, and I suspect it's going to figure this out for me, and it knows it's .input, because one of the nice things about using Ghost Text AI in this environment is it can see all of my previous messages. So it knows exactly what I've got. So that makes life nice and easy. So I've called my function. I've got my answer. That's great. And so this next bit, we know we want it to look like, no, this. Yes, this is our content. Here. Great. So let's create our, say, tool result content. And so the tool use ID is the tool use block dot, and you can see it right here, ID. And the content, okay, that's a string, right? And so actually in practice, this is JSON. So we use json.dumps to grab our result. Okay. No point putting this on multiple lines when one line will do. So Control J to join. And we can just double check, of course, that looks okay. So we don't end up with bugs. It's from there. Okay. So you can see I've hardly had any bugs today, right? And that's because they're just such small steps. No problem. So now we need to basically put all that together with the appropriate user and assistant. So there's a nice tiny little function that we might just take advantage of from Claudette called make messages, and that's just going to go through and add the user and whatever stuff to it. So make messages, I'm going to pass in, and I'm going to have exactly the same messages that we saw. There's going to be the prompt, first of all. And then we need the responses content, right? So that's what, it's my trackball doesn't work. See, we've got the assistant response content here. So we'll have that. And then finally, we need our tool result contents. Okay, so we'll call that our messages. That's like our history, right? We're kind of generating it by hand. Let's see if that looks the same. Role user content, role assistant, role user. That looks the same to me. So assuming that it is, we can then say, okay, call the client, passing in this created history. You get a new response. Okay. So you can see it's getting there. And so we generated the same thing as the history. We got the response. And here, believe it or not, is where I'm going to leave it, because that's your homework, right? I've gone from the start, I've gone down, 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 and there's like half a dozen more messages now to create the loop where I want you to have a function called do loop. It should not call Claudette's Toolloop. It should only call C, our client. You should be able to pass it a prompt and a list of tools, and it should do it all for you. And to do that, I recommend you start by importing this dialog. Okay, so if I hit this publish button here, share this with your friends. You're all my friends, so you may use it. Okay, there's the dialog. So if you now click here and head over to here, hit upload file and paste it in, you will have a new dialog. Submit. I think actually, and it's going to give it the same name. So it didn't work for me because I've already got it. If you haven't done language model programming before, this homework's going to be hard, right? If you have, it'll be trivially easy, but do it anyway. But do it because it's going to test whether you get it, and if you can do as small a steps as possible, right? And if you're confused, like import my dialogue, and if you're confused, like, why did Jeremy do that? How did this happen? Like, just ask, right? Hit A to add a new message above, or B below, and add a prompt. Make sure you're in learning mode. And if you don't get its answer, it's just say like, I didn't understand that. So if you hit Option Enter or Alt Enter to submit, it'll create a new message underneath. So you can immediately put underneath it, I didn't understand that. Can you take me through an example? Like, go at your pace so that you don't kind of fall off this thinking like, oh, I kind of vaguely understand the idea, I think, right? Do the homework, study the dialogue. And if Solveit doesn't help you well enough, ask it first. Jono, what else do we need to mention?
I guess yeah, also be sharing if you use this to do fun things. If you create some silly agent that does something entertaining, we'd love to see it.
Yes,
despite our
please.
anti-agent rhetoric, we do still like people seeing.
We're not anti-agent, just use it for the right thing.
Use it for the right things, or for very amusing and silly things. Yeah, then also maybe Jeremy, so for next week, besides finishing off this demo and saying, okay, how do I wrap this up into a loop and make that do loop function? Other things people should be looking at? Are we going to be looking at Advent of Code again, or what are some other pieces of prep that people should do?
Yeah, so the purpose of this course is that it's kind of twofold. We're going to keep trying to show you cool things like what's an agent and how do I use it, or like teach me regular expressions, or how do I use NumPy, what's broadcasting, how do I administer a Linux server. These are all examples of things we'll do in following lessons. But for each one, the purpose is really going to be about like, look how dramatically easier it is to do these things and to learn these things if you do them in small steps and you kind of take advantage of this approach. I would say practice. Advent of Code's a great place to practice because you can go down to find a problem that's at your level, or a bit beyond you, and see if you can use this approach to do something you weren't sure that you could do before, or to use something that's not too beyond you to learn like how to do it faster or more concisely, learn something better about the programming language or algorithms and data structures. Or practice the stuff from lesson one. We've got quite a few folks, quite a few students have written some really great articles and shared it with us. It's really all about practicing. Do you have any other suggestions, Jono?
I guess just the final prompt. So while you're working on this, so again, the thing that Jeremy said, the main homework, finishing up this notebook, the good piece of self-reflection to assess, and I think these are questions that Jeremy had people asking last time, is when you get to the end of it and you're done, did you write most of the code, or at least understand every small piece before you did it? Are you learning things and having fun? Um, are you then reflecting on like, is there a nicer way I could have done that? So for example, you write your do loop function and it ends up maybe looking a little bit tangled or complicated. Are there ways that you can break out small pieces and redo it in a more elegant way? Um, okay, so yeah, reflecting, is there a better way I could have done it? Have I done it in small pieces and understood each piece? Um, thinking back on how you felt during the process and what worked and what didn't. Are there any other final pieces of reflection in that list?
Yeah, well, I mean, so in the
Hmm.
next lesson, also, we're going to dig deeper into the one of the inspirations for this, George Pollier's classic math book, How to Solve It with Code. Sorry, not with code, just how to solve it. There was no code in 1945 when he wrote that. And we'll talk about, maybe encourage people who might even want to try buying the book, which is a whole book. It's all math problems rather than coding problems, but using very similar techniques of like how to solve problems. Everything we do in the world, as we discussed, last week, or a very large amount of it, can basically be described as how to solve a problem. So that's we're going to keep digging into this every lesson until we're done and beyond. But I hope people enjoyed learning how agents worked and feel like they are a little closer to understanding this mystery than they were when they started. And thank you very much, Jono.
Yeah, thanks everybody for sticking with us. We'll see you in the next lesson.
Bye.